Hello and welcome. Oh, it's exam review. I got excited. Sorry. Hi. So, exam 1 review. Let's talk about the topics, the list of the shopping list, right? So, we are looking at exam 1. So, chapters 1 and 2. Chapter 1 is functions. Chapter 2 is limits. For chapter 1 we have 1.1 through 1.4. For chapter on limits we have 2.2 through 2.7, remembering that 7 is definition only. Exam is going to have, say, 10 problems. I would say 3 to 4 problems chapter 1 and the rest chapter 2. And it's 100 points, so you guys answer as much as possible. Make sure you show all the work and all that good stuff. Bathroom before the test, not during the test. No phones and no graphing calculators. That's the rule of the college, so we can get you to transfer these courses. So no phones and no graphing calculators. You can bring in scientific calculator with trig and ease and stuff like that. Or you can bring the basic calculator that only has those basic operations. Or you can show up without a calculator. That you don't need one, then perfect. Whatever. Now, run. So what do we have for topics? Now, number 1 is the definition of the function. We said about, I gave the definition on the first day, and I did tell you that it's going to be there on a first test for 4 points, so make sure you don't mess it up, right? Because that's the 3 points. Now, what else are we talking about regarding the first chapter? Well, definitely we have the domain/range. We have the graphing, which is shifts and reflections. We have function composition. And finally, we have inverse function. So these are all chapter 1 concepts. And any of these, well, first one definitely, anything else, right? So this is all chapter 1. All of this stuff is possible. Then we jump into chapter 2, which is limits. And for limits, we have a whole bunch of different ways to take the limit. One way of taking the limit would be to use the graph. Another way would be to use the chart or the table of values. And we did that, both of these in 2.2. Then plug in. If the denominator is not 0, then we have the algebra. With all of those, we had the squeeze theorem. That's it for 2.3. Then we had the vertical asymptote, and every year I have the same issue, so I always have to say it. What you know from before doesn't count anymore. So you setting the denominator equal to 0 and claiming vertical asymptote, we did show in a class that doesn't work every time. So I'll write it in blood. You must know the definition. Limit x goes to a of f of x giving you positive or negative infinity, vertical asymptote is at x equals a. So the red stuff is what you must know. The other stuff that you know doesn't matter anymore. Horizontal asymptote, again here in blood, limit x goes to positive or negative infinity of f of x, giving you a finite value, so the y equals L is the location for horizontal asymptote. So these are the asymptotes definition. You could be asked to just state them, or you could be asked to find the asymptotes, or both, whatever, right? There is also the slant asymptote, but that one is the long division, so no calculus there. That's a kind of lower probability to get the slant asymptote, also known as oblique asymptote, depending on which book you read. So vertical asymptote, horizontal asymptote, slant asymptote, 3 types of asymptotes. They're all straight lines, right? And then after these asymptotes, we have the end behavior. And behavior, there we go, which is, the graph with the 4 ways it can go. So it can be a graph, could be just a question. And finally, we have continuity. We have 2 more things. So continuity. The continuity is breaking down at the point. Continuity at the point, and that would be the 3 rules. Again, it could be a problem, or it could be you just stating what the definition is. Then we have global continuity. Then we have the those 2 theorems. So 2 theorems for global continuity, so you can do the problems. And finally, we have precise definition of the limit. That's 2.7. You have the statement and two graphs. So that's the 2.7 part. No problems on that one, just the statement and those 2 graphs. So that's the list of all of the topics. We are not including 2.1 in this exam because 2.1 is actually going to be together with 3.1. Now, we did go over 3.1 and 2.1 was in there already, but that's going to be the part of the next test. Now, 3.1 is the calculation of 3.1 is definitely on the test because it's just the limit of the difference quotient, but that's actually 2.3. So I'm just going to write it this way. I'm going to say, oops, 1 second, there we go. I'm going to say calculations in 3.1 are the same as 2.3, and 2.3 calculations, well, that's definitely on the test. So when we talked about 3.1 in class, I said, you already know how to compute this, we're going to give it a name. So we computed the limit of the difference quotient, and then we called it the derivative, right? So nothing new in 3.1. 100% of 3.1 calculations are done in 2.3 when you find the limit of f of x plus h minus f of x over h. So that calculation is actually the part of both exams, exam 1 and exam 2. It's just an exam 1, I say find the limit of the difference quotient, or just find the limit. On exam 2, I say find the derivative using the limit definition. So it's the same problem, just different wording depending on which chapter you put that problem in. And that's that. So this is the list. As I said, 10 problems. I had to write these in red because year after year after year you go and start, writing the P's and Q's and those rules and try to remember this is meant for every single problem you can run into because it has f of x. It's not forcing f of x to be polynomial or anything like that. It just says f of x, which means anything, which means you can plug in tangent, you can plug in e to the x, or you can plug in. So those old things you learned in pre-calc are now upgraded to these two statements, and they cover all functions forever and ever, where stuff that you learn in pre-calc, it only applies to a particular case. So the example here is, we can talk about 1 over x, for instance, right? Well, that's a rational function polynomial divided by polynomial, right? 1 as a constant divided by x to the first power, right? And you can say, oh, the degree in the numerator is smaller than the degree in the denominator. That means that the horizontal asymptote is at 0. And yes, you learn all that in pre-calc, but you're simply taking the limit as x goes to infinity of 1 over x is 0. And there you go. Ha at y equal 0. Done deal. This is the way we do it in calculus without memorizing any special rules, any special cases, right? And the other important aspect of that is also when you memorize the rule for a specific function, then it doesn't work on something that is not that function. So the limit of e to the x as x goes to negative infinity is also equal to 0, so horizontal asymptote at y equals 0. If you go with the limit e to the x as x goes to positive infinity, then you're going to get positive infinity, and that's the end behavior, which is going to be end behavior, which is going to look like that. So you have to be careful, right, of what you're going to get if you know what type of the function you have. But the moral of the story here is to study definitions and theorems of calculus. What you have and what you know from before is going to support these ideas, right? But the course focuses on theorems and definitions that are given in this course. Now, as I go through, pre-calc review, boom, the first thing, red definition for the function. I told you it's going to be there. Then we go let's go infinite limits, right? You go immediately on the top, infinite limits. Oh, gives me infinity. Go down, boom, red definition. And clearly stated in the red definition is the formula to calculate the vertical asymptote. So when you have the formula, right, for f of x, any function can go there, not just rational, not just trig, but any function would go in there, and that's why we have the red definition. So you go through all of the notes. Everything that I wrote in red, or those blue theorems that we had in continuity and so on, right? That's the stuff that you need to know, be able to state, because these are the ways to do the problems in calculus. It's no longer just plug in the number and compute like pre-calc. You also have to know theorems and definitions so you can do certain problems. And as you can see, I am using those, right, definitions and theorems in problems. So that's what's important for the exam. As I mentioned, about 10 problems, 100 points. I did not write, so the exam is about 80 to 85 minutes. So if you have 10 questions on 80 minutes, that's 8 minutes per question. Some questions you can do much faster than that. So, still. The back page of the exam would be can be used to do some artwork or something. There's a whole bunch of students listen, and then can be short stories, poems. It's reserved. The last page of the exam is reserved for you to be creative and put something either funny or something nice, whatever, which is going to break up my misery while I'm looking at everything else and put me in a good mood too. Yeah. All right. Any questions, concerns? Yeah.
3.1 and 2.
Calculation, yes. The concept, no. So I'm never going to say the derivative on the exam. But the calculation, which is why I put that 3.1 equals 2.3, but calculation only. And I'm going to ask the same question in exam 1 and exam 2. I'll just change the wording. Exam 1, I say find the limit. Exam 2, I say find the derivative using limit. It's the same problem. It's learned in 2.3. 3.1 just gives it a name. Any other questions, concerns? Yes?
What did you mean by slant asymptote?
Slant asymptotes are oblique asymptotes. Y equal mx plus b.
Oh, that one. Okay.
Yes. So slant asymptote or oblique asymptote has the form of y equal mx plus b, and you get it through long division. You can also use synthetic division, but that's a specific only to if your denominator is a linear function. So slant asymptote only occur for rational functions where the exponents are 1 apart, but long division will show its value. Anything else? Yes.
So I don't know if I was reading a homework or one of the quizzes, but the problem popped up and it said find the inverse, the cosine of the inverse sine of 7 over x.
Beautiful question. This will eventually pop up in Calc 2 and Calc 3. We are not going to use these calculations a lot in Calc 1. I don't think they show up at all, actually, in Calc 1, this particular one. But it will come up. These problems you have seen in the pre-calculus, and the way to solve this is to draw the triangle and use the sine as a what? Does anyone remember? Opposite over. Beautiful. Opposite over hypotenuse. And when you write opposite over hypotenuse, you can calculate the third side using Pythagorean theorem as square root of x squared minus 49. So, right, to get this, you would use a squared plus b squared equals c squared, Pythagorean theorem, for the right triangle. So now when you have this, you will write the inverse cosine looking at the triangle, and that is adjacent divided by hypotenuse, so square root of x squared minus 49 divided by x, and then these two cancel, and the answer is square root of x squared minus 49 divided by x. So inverse sine, cosine of inverse sine on top equals to this, equals to this, equals to that. So that's the answer.
Will something like that be on an exam?
Definitely not. As I said, it's for Calc 2 and Calc 3. Okay. This is probably one of the review questions from Chapter 1 because it was reviewing trig. But you are definitely going to see this in Calc 2, Calc 3. It's coming back, and difficult too. So those of you who are taking more Calc courses, this should not appear. I don't think it appears at all in Calc 1. I don't think so.
I think this was on the quiz.
Was on a quiz?
Yeah.
Probably when we upgraded from 2nd to 3rd edition, when the problems were transferred picked up a problem like this. It should not be there technically, because this is a pre-calculus 2 question, right? It's a trick question, it has nothing to do with calculus, but we are going to use this a lot later on for parametrization and a whole bunch of other things that polar coordinates are going to use this. So entire Calc 3. Yes?
Is there, I'm just looking at my math lab, or my lab, for the quizzes, even though they're past you, if we did them, is there any way to still open up your answers?
I don't think so, but you don't need to do that because you can always go into study plan, and then you also have the sample exam under sample tests. If you go to assignments and change quizzes and tests, scroll down, you will see sample exams. So you're looking for a chapter 1 post test and chapter 2 post test. Those are the sample exams that you can take and see what are the concepts that are missing. But through the study plan, which is a different thing, right? Through study plan, you can access any problem of any chapter of any section. Study plan is the best thing in the whole software. Lets you travel to time. Anything else? Questions? Oh, things to lose point here. I never did this before, but let's try, see how it goes. So you're my guinea pigs now. Ready? Easy ways to lose points. How about that? Writing something like this as the answer. Hold on. Answer, limit 7. Like, great, -1 notation. The answer is just 7. You don't put limit. Great. What else? Oh, horizontal asymptote equals 6. -1 notation. The correct way is just to write 7. The correct way is to say y equals 6. It's a line. Another one to lose points. Vertical asymptote is equal to 3. Boom, -1 notation. Correct way is to write x equals 3 because it's a vertical line. These are the things that you lose points on because you're not paying attention in class, right, in terms of the way the stuff is written, and then you come up with your notation that is meaningless because it's not defined in mathematics. So, wrong and right, right? So that's one of these are like the top 3 ways, right, to lose points. Now, if you have, let's say, 6 or 7 limits to take, doing this 6 or 7 times, that's minus 6 or 7 points. And then some vertical asymptotes here and there. You lose a whole grade over just writing things the wrong way. So make sure you don't write this. Oh, and the arrows also for the equal sign. Because arrows in chemistry are used to show that reaction can go only one way. In mathematics, equal sign is there because it goes both ways. So there is a reason why chemistry invented arrow as a notation, because you have a reaction, you put together, 2 things in chemistry and you get a third thing and you can't go back once it mixed. You take a little bit of yellow and a little bit of purple, you put them together. If it doesn't explode, maybe it's blue now, and that's it. There's no going back. In mathematics, we use equal sign because you go both ways for all of these. So that's why there are no arrows in mathematics unless you are saying x goes to a, in which case it shows the motion of which way you are going. it is not equal. It doesn't say, if it says x equals a, then it's a completely different story. So arrows are also something that we should not be using. Yes?
So if I put an arrow in other word.
A is just -1. It's not a big deal. It's not a big deal. -1 in 10 problems, I mean, it is a big deal. But if you put an arrow in one problem, it's not going to damage.
Or like in between steps, like if I'm working out my problem.
Yeah, we put the equal sign because from each step you can go back or you can go forward. That's why we use equal. You want, okay, sure. Okay, so -1 per arrow. He just made it worse. I was about to put -1 per problem, but he wants per arrow, so fine.
What about a double arrow?
Unless you're going to use this kind of arrow, then I'll have no problems. That's equivalency arrow. Yes. It's called mathematical notation. It's the only universal language we have. So this is when we start discussing this, I usually, bring up my friend who had to work in Germany as engineer. So he was a test engineer for a company that was contracted to test air conditioning on new cars, on prototype cars. So this poor guy had to drive prototype cars from Germany to Italy, German prototype cars, from Germany to Italy on their autobahn that has no speed limit on it. So it's like Audis, BMWs, Mercedes, and all of these cars. And then we are talking about next year's model or the 2 years in a development ahead to test the air conditioning, and then he had to do the mathematical equations to show things. So obviously, language barrier is there, so they use mathematics to communicate. Imagine if he used arrows. I had no idea what was going on. Any other questions, concerns? How about some problems, guys? Looks like it's going to be. Looks like it's going to be a really good exam then. Yes, you know everything.
How do we find the limit for a fraction that has a square root as a denominator? Or are we supposed to take derivative?
No derivatives. This is the first exam, right? The square root doesn't matter where the square root is. If you're looking for the one with the infinity, you will still do the same thing. Divide by highest power. Then when it goes under the right, if you have the problem, I can do it. That's the trick. I did say last class. I bring the problem so I can do that. Any section, whatever you want. You can ask any section you want, please. If you have a question. Yes?
Is it by the highest power in the denominator or the whole problem?
The whole problem. But remember to cut all of the exponents under the root in half.
Because in the lab it said, there was one question that said the highest power of x in the denominator.
No. It is, if there is a specific request, you try to follow it, right? But in general, it's the highest exponent in the problem. And then again, whatever is under the square root, you have to cut in half. Whatever is under the cube root, you have to cut in 3, and so on. Yes?
There was a question on one of the quizzes. That's why I asked if I could read it or not. I thought I took a
Sure.
picture of it, but I didn't. I'm trying to remember it. It was a piecewise function. I think it was. I think it was 0.
Okay.
The limit as x approaches whatever is equal to 0 if x is less than
Something, okay.
something. I want to say 1.
And then there was a function underneath.
I don't know. It was like, I read it that way.
Maybe if you take a look at the textbook in the problems. Yeah, you can open the textbook in my MATLAB and just take a look at the problems.
I got it. So this is an example. It was something like this. So if x is less than 1, then the limit equals 0.
If x is less than 1, then the limit of the function equals to 0, okay?
And then the second part of the function was if x is greater than or equal to 1 and less than 4,
Okay.
then the limit is equal to x squared plus 1.
Give me 1 second to fix this. So, and less than 4,
Yeah,
then the limit of f of x is,
x squared plus 1, let's say.
oh,
And it was asking if, like, it was asking what is the limit as x
Oh, okay.
approaches 1 from the left, and what is it from x?
now I understand. Okay, so this is not the way to write the problem. The problem should be written like f of x is equal to, we have a 0 for x less than 1, and we have x squared plus 1 when x is stuck between 1 and 4. What is the limit as x goes to 1? What is the limit when x goes to 1 minus for the left side? And what is the limit as x goes to 1 plus, which is from the right side? There we go. I'm just going to kill that. Okay, so now we have a piecewise function. You can graph this if you care, or you can just use the calculation. I mean, if you have to use the chart or values or whatever. I'm going to graph this because I can. I'm going to draw XY coordinate system and make this invisible barrier at 1, because to the left of this invisible blue barrier, I'm going to have the function 0. That is, and it's going to have an open circle at 1, and the function is going to be on the x-axis, because the function value y is 0 all the time for all of the x's to the left of x equals 1. To the right of x equals 1, we have to follow the function of x squared plus 1. Now, x squared plus 1 is the function that you can, it's a parabola, right? So x squared plus 1 should look like this, right? But we only need the half of it, and then it needs to start 1 unit offset, because we are starting at 1. You cannot have, so the function will should start at, because it's plus 1, that's a shift up by 1. So the function will actually start here with the black dot at 2 and go up as a parabola. All right? Yes?
What if it was, what if it was x squared minus 4?
Then it would start here, and it would actually go through the point of the, so whatever, it doesn't really matter. I mean, obviously the result of the problem, the limits over here will matter. That will change the answer, but the graph, plus minus 1 just shifts it up and down.
Right.
So now, to answer the question the way it's given, I'm going to just look at the graph and say that the limit from the left, which is 1 minus, is going to be 0, because we are approaching, right, the red, we are approaching 1 from the left, that's the Juliet, and as you can see, Juliet always sees 0, is always 0, 0, 0. All of the y values for Juliet are 0. Now, for Romeo, on the other side, when he approaches 1 from the right, he's going down this line, so he's going to end up at 2. And now we have that theorem which states that if these two are different numbers, the limit does not exist. So I'm just going to go and pull these two together into the limit x goes to 1 from both sides does not exist, because these two are different values. So that was the theorem that we learned in 2.2. Left limit and right limit must be the same. Now, since you asked the question, what would happen if this function was below, so if the function was like this, then the limit would be 0, because the Juliet would get to 0, Romeo would walk down into the 0, and they would meet at 0. In this case, the overall limit would be 0, because all three limits would be 0. But that was not the original question, so I'm just going to get rid of it. Just want to mention since you asked. So for piecewise functions can click in, or they can be disconnected. So you have to take a look at each piece, right, the one-sided limits, and if they are the same value, that means they click together, then the overall limit is that value. And if they are disconnected like this, that means there is a jump there. We call it the jump discontinuity, which means the limit does not exist, and that's it. That's the end of the story. Cool. Yes?
I have a silly question.
I'll try to give a serious answer.
When the function is x squared plus 1, why is it the vertex at 1, 1? Why is it at 1, 2?
No, vertex is at 0, 1. This function would go like this.
Okay, yeah,
This is the way the function would go. So the vertex is at 0, 1. It's just, vertex is at 0, 0. You shift it up 1 unit, so it goes to 0, 1. It's just a terrible graph, because I'm walking and drawing. Right? Anything else? Yes?
For the question I asked earlier about how to find the
Limit? Mm-hmm.
Yeah, square root of the denominator. From the question, limit is x goes to 3 for x minus 3
Okay, x goes to
over
3.
square root of 4x plus 13 minus 5.
Excellent. Right. So here we have a question which we can try now, see what's going on here. So I have if I plug in, so anytime you have a limit, the fastest way to solve the problem, if you can, is to plug in. So now if I plug in 3, I get 0 in the numerator. When I plug in 3, I get 12 plus 13 is 25. I get 0 over 0. Right? So this problem is one of the evil problems, because we have 0 in the denominator. We cannot solve it by plugging in. So let me just point the arrow right here and say cannot plug in. All right, so now we have to go to our bank of algebra tricks and pick an algebra trick that would solve this problem. If all of the algebra fails, you can always pick values to the left and to the right of 3 and see where the values go in a chart. That's always an option. That solves 100% of the problems. But maybe we can deal with algebra and solve this problem in a different way. So here we go. Limit x goes to 3, x minus 3 divided by the square root of 4x plus 13 minus 5. So the tricks are factor, cancel, rationalize. Hold on, rationalize. I have a square root. Let's try that trick. So we are going to use what we call the conjugate, right, which would be the square root of 4x plus 13 plus 5 divided by square root of 4x plus 13 plus 5. So what I have written there in orange, it's 1. So when I multiply by 1, I don't change it. I will change the appearance of the problem, though. So now limit x goes to 3. I have x minus 3 times square root of 4x plus 13 plus 5 divided by, now when these multiply in denominator, I get 4x plus 13 minus 25. So that's what I have when I do the foiling. The cross terms will cancel. So now I have limit. Observe that I am copying the limit in every step. I am copying the limit because the notation requires you to copy the limit until you get to use it, right? So we have to keep copying the limit here. We have x minus 3 square root of 4x plus 13 plus 5. And now I have 4x minus 12. And at this point, I can factor out 4 in the denominator. And I'll have x minus 3 times the square root of 4x plus 13 plus 5 divided by, when I factor 4, I get x minus 3. And this is where these guys cancel. So now I have just the square root plus 5 divided by 4, and I can plug in. So let me write it in blood. Now I can plug in. Now I can plug in because no more 0 in denominator. So when I plug everything in now, I'm going to get square root of 4 times 3 plus 13 plus 5 divided by 4. That's going to be 10 over 4, which is, I believe, 5/2. So the answer should be 5/2 for this. And then as it goes, every time you guys have a problem to solve, you can either check it using Wolfram Alpha or Mathematica, or you can graph and look at the value that it settles right at 5/2, right? Is the y value for the one that you're interested in at 3. So, you know, you can pick whatever. Let's try graphing this problem and see how far that gets us. So we have x minus 3 divided by, now this is going to be a square root of 4x plus 13, and then escape the square root minus 5. There we go. Oh, it's terrible, but maybe we can zoom in enough to see that at 3 we have 2.5. So here is where the 3 is, 2.5. You see that? It's perfect. And here's 3, 3.5, 4. So we see that at 3 we are getting 2.5. Now, again, as I said, Desmos is not programmed well enough to show us the open circle when the open circle is needed. So this one would have an open circle there at the graph. So it's not continuous through that value. It has to end, right? It has to have an open circle there. But as I said, Desmos is not programmed to the point where it would show the open circle what it should. But if you graph this on your calculator, the graphing calculator, the one that is banned for the exam, right? There will be a missing pixel at this location. So if you graph it there, you should be able to see it. Happy? See? Yes.
For 3.1, when we're doing finding the slope of a tangent line, is that
No slopes of the tangent line. That's the concept for the next exam. Slope of the tangent line, again, I'm not going to ask it that way. I will just ask you to find the limit. So the whole procedure is there. It's just it's not going to mention the tangent lines. It's not going to mention derivative or anything. It can either say find the limit, and it just has one of those problems, or it can say find the limit of the difference quotient for the function. So you have to put together the function and then find the limit. So
I'm just unsure how the question is going.
there was a question that we did in class with 1 over x in 1 over x or something.
Yeah, that's
So-
find the derivative of it, but how how would you word it?
Just say find the limit. That's it. But let's jump to 2.3 and find the exact question. So there it is. Bah, can't see it. Hold on. There it is. So compute the difference quotient for the function. And you create the f of x plus h piece, you plug everything in, run the calculation, and get 2x as the answer. So this is in your notes, or it's in Canvas notes, right? So you can find this example. Let me see, the previous example was the previous example is the same one, except this one just said find the limit and just had the stuff. So this is the difference quotient computed for function 1 over x. So if I just say find the limit, it counts as 2.3. If I say find the derivative or tangent line, it counts as 3.1. Same question, same calculation, just a different name, right? Depending on which section you go to, right? So that's the same. So what you're seeing right now are two examples that are worked out, and the wording is simply find the limit. We are not going to mention tangent lines or derivatives on this. Exam 2, same question, but I'm just going to say find the derivative, and it's the same question. What about before that? No, before that is different stuff. So you have these two examples. One is for 1 over x, and the other one is for x squared plus 4. Technically, you can have anything in there as long as you are able to grind through algebra, because all these problems will grind algebra a little bit and eventually cancel that age in denominator, so you can plug in age equals 0 and be done. Anything else? Going once, going twice. Yes?
I have another new question. It's from the quiz. It says define the limit of the limit as it goes, as x goes to negative infinity.
Hold on, that's for today's quiz. I can't do today's quiz. I can do any previous quiz, but not today's. The quizzes are there for you to practice, and you still have till midnight to figure it out. The quiz will close at midnight, and then the new quiz tomorrow. If you write the question, you can stop by tomorrow, office hours, and ask. Right? You can write the question or take the picture with the phone, or you can also print the question. There's like so many things. You can email it to me. Right, but today's quiz is today's quiz, right? You gotta pass it. And I can explain the details of it. Anything else? Yes?
Shows a problem where
You remember, you have to give me the problem I
that's
solved.
the thing I don't have. But for the intermediate value, value.
Yeah, I don't have to worry about that. It's only in a lab. Anything else? All right.